Today, we celebrate the life of our dear friend. Time keeps moving forward, but these memories make it feel like time stopped for us because your presence feels like yesterday.
Things we don't really understand why we laugh for a moment and start to cry. We were crazy. Now that the end is already here, we reminisce about old yells and cheers, even if our last hurrays were never clear. Farewell to you, my friends. We'll see each other again. Don't cry, 'cause it's not the end of everything. I may be miles away, but here is where my heart will stay with you, my friends, with you. Yesterday's a treasure, today is here. Tomorrow's on its way, the sky is clear. Thank you for the memories of all the laughters and tears. And not to mention our doubts and our fears, the hypertension we gave to our peers. It's really funny to look back after all of these years. Farewell to you, my friends. We'll see each other again. Don't worry, 'cause it's not the end of everything. I may be miles away, but here is where my heart will stay with you, my friends, with you. Farewell to you, my friends. We'll see each other again. Don't worry, 'cause it's not the end of everything. I may be oceans away, but here is where my heart will stay with you, my friends, with you. With you, my friends, with only you.
Kamusta kayo mga pre? Maayos ba dyan sa inyo? Maayos ba panahon dyan?
Okay lang naman kami dito. Sa amin, tahimik. Parang kahapon lang, 'di ba?
Ilang taon na
Saka,
naman, no? Ilang taon na naman? Parang nito nakaraan lang, mag-aasawa ba tayo nila Bert?
oo, sariwang-sariwa sa akin. Yung bonding natin na ganito. Yung pagtambay natin.
Oo, huli
Yung
pagkikita natin ganito din.
Ganito lang
Pero
din.
mahangin. Oo,
Ganito lang din ang panahon.
tama.
Sakto lang.
Hindi naman umuulan dyan.
Clear ang weather sa amin.
Oo, mukhang dito din naman. Paano yung tradition natin? Makakapagpalipad pa tayo ngayon? Sige.
Ang nakita kong weather forecast, ang prediction ng NAIA is by 3 p.m. magiging 13.8 miles per hour ang hangin, and by 4 p.m. magiging 11.5 miles per hour ang hangin, which is totoo naman kasi kaninang tanghali pa ako mahangin dito. Sa inyo ba? Kamusta rin ang weather dyan?
Gano'n din naman, makulimlim din at mahangin. Siguro naman magkakaparehas lang tayo, magkalapit lang din naman tayo.
Tama-tama.
Pero kung makakapagpalipad man tayo, hindi kaya umabot sa dagat mga letters natin? Mamaya pag pumutok yung lobo, sa dagat lang din mawagsak. Hindi naman kaya?
Sa tingin ko, posibleng malaman natin yan. Magkakaroon lang tayo ng ilang assumptions. Ayun, titignan muna natin ang panahon. Babalikan natin. Ang sabi ng weather forecast ng NAIA is by 3 p.m. magiging 13.8 miles per hour ang hangin. And by 4 p.m. magiging 11.5 miles per hour ang hangin.
So, for today, we have gathered the data of wind speed on Monday, November 1, 2021 in Manila. At 3 o'clock p.m. with the 13.8 mile mph wind coming from the east, the balloon is released approximately 10 meters above the ground. We assume that the balloon is spherical as it increases volume. In the process, mass is introduced inside the balloon, means that the volume of the balloon increases with the mass. The balloon keeps spherical because the pressure is equal inside and outside of the balloon. We use the equation of state to express the relation between the internal and ambient pressure. The gas with lower density than the air is introduced when we use helium to produce buoyant force. The temperature is equal inside and outside the balloon for the floating state to fully inflated state. The net force is equals to buoyant force minus weight of the helium minus weight of the balloon minus the weight paper, as the density of air multiplied by V equals the density of helium multiplied by V, plus the mass of the balloon plus the mass of the paper. The pressure constantly decreases as altitude increases, which happens at the same rate inside and outside the balloon. As a result, the volume of balloon expands. We determine the relationship of pressure and density decrease in the troposphere, so we come up with the equation below. Inserting equation A to relate the balloon's volume with increasing altitude. Differentiating the equation and substituting x and y, we come up with the equation E. Change of radius with the respect to change in density, determining the rate of change of density with respect to the height with the equation you see below. After that, differentiating the density of air, inserting equation F into right side of equation E, and then substituting the equation below as the right hand side of the equation E. Further derivation of left hand side of equation E and further derivation of right hand side of G. Below, we see the rewritten form of G, where the given are stated also below. We come up with the problem solving equation, which is the a boy released a 9.4 1104,833 times 10 raised to 4 kilograms balloon filled with helium with a density of 0.1786 kilograms per cubic meter. The paper attached under it weighs 1.2096 times 10 raised to 4 negative 4 Newton. Initially, the balloon inflated to diameter of 8.5 inches. It was found that the balloon would pop if it reaches the diameter of 12 inches or 1 foot. If the temperature is at 288.15 Kelvin, at what height would the helium balloon pop? A is equals to negative 0.0065 Kelvin per meter. In conclusion, the answer of the solution is 12,528 meters.
For those who are curious of how it came to that, we use the non-differential form of the rewritten form of G, which is written as equation I. Then we substituted the given values of I. We substitute the values of I to the equation, which now becomes approximately 12,528 meters. Given that height, and given the recorded data of NAIA, how far would the balloons go? We assume that the wind is consistently going at east. Again, here is the given wind speeds and the prediction at NAIA: 13.8 miles per hour and 11.5 miles per hour at 3 p.m. to 4 p.m. respectively. The instruments are placed approximately 10 meters above an open field. But despite the small difference of the equivalent true airspeed, we still find the true airspeed and the equivalent airspeed of the balloon at the given height. So for the initial setup, we assign the bottom of the balloon as the height that the balloon would reach. This would help us indicate that the balloon has reached ground. And then, given also the height of the ceiling, we see from this setup that upon reaching the ceiling, the balloon takes 1.86 seconds to do that. And then the total height is equal to the height of the ceiling minus the diameter of the balloon. That way we find that the acceleration of the balloon upwards is 1.3367307 meters per second squared, as seen below. However, that acceleration only takes into account the buoyant force of the balloon with the air minus the weight of helium minus the weight of the balloon itself. After finding the buoyant force, given those weights, we now compute for the net force, including the lengthwise length of paper, whose width is 1/4 of the original short band paper. Once we take that into account, we determine that wait lang. Papakat ko na lang kaya natin.
Pwede ba i-stop yung recording kasi play mo ulit?
For this problem, we determine the vertical acceleration of the balloon by this setup. For this setup, we take into account the height of the ceiling and the diameter of the balloon. We also assign the bottom of the balloon as the height that the balloon has reached. And to determine the time that it has reached a given height, that was timed in the setup, and the net height was the height of the ceiling minus the diameter of the balloon, as seen in the figure. In the setup, it was also found that it takes approximately 1.86 seconds for the balloon to reach from ground to the ceiling. In the setup also, we consider that the balloon only considers the buoyant force of the balloon minus the weight of the helium minus the weight of the balloon. For this problem, we also have to take into account the overall force and the acceleration when the paper is attached with a paper which contains the messages of our friends to our deceased friend. Anyway, this is the computation of the acceleration and the buoyant force, considering that there is the buoyant force of air minus the weight of the helium and the weight of the balloon. After determining this force, we subtract the that force, the weight of paper, which is also computed below, and we find that the net force is 0.00011722229 newtons. And from that, we also find that the total mass of the setup is equal to the mass previously computed and given, which are also estimated. We see here that the total mass is 0.043728887 kilograms, and the net force is 0.05741082 newtons. And from here, we deduce that the acceleration is around 1.31288 to 302 meters per second squared. And it is also important to note that this acceleration goes upward. Now that we determine the upward acceleration, we next determine the equivalent airspeed of the measurements made by instruments at NAIA. So we use the formula of the relationship of true and equivalent airspeed. Despite the small height from the sea level, we still take into account that difference in height to find the most accurate equivalent airspeed possible. Those equivalent airspeeds were then used to find the true airspeed at the given height at which the balloon has popped. The given height was computed earlier, which was 12,528.88 meters approximately. So the true airspeed at 12,528 meters at 3 p.m. is 2.987 meters per second, and the true airspeed at 4 p.m. is, okay, we have to revise. Again, the true airspeed at 3 p.m. at 12,528 meters is 12.4948 meters per second, and by 4 p.m. the true airspeed becomes 10.4123790. The acceleration at that altitude is equal to negative 5.784 655,002 times 10 raised to negative 4 meters per second squared. The negative direction indicates west, and we also consider that the acceleration upwards is still the same as before, which is 1.312 meters per second squared. To find the total time to reach up for the balloon to reach upwards with the setup, we use the kinematics equation as seen in the solution. We translate the equation and we find that the time to reach the given height is equal to the square root of 2 times h over the acceleration. The computed values earlier are inputted to the equation, and we find that it takes 148.72 seconds for the balloon to reach from ground to the maximum height that it pops. The total length of the horizontal length that it covers at that given time is also found with the kinematics equation as seen below, but we assume that the initial position is equal to 0. So we substitute the given values and the time, the acceleration, to find that in those 148 seconds, the balloon has traveled 923.0132 meters. horizontally, again, it takes 923 point. Okay. Again, at those 148 seconds that the balloon has risen to its maximum height, it has already covered 923.0132 meters horizontally. That is only for the upwards direction. For the downwards direction, we still use the same kinematics formula, but we assume that the acceleration of the object is now due to the force of gravity. So, given the same values, we find that the time to travel the balloon and the paper to the ground is 50.55 seconds. Then we use the kinematics formula to find the initial airspeed at the maximum height, which is 12.4876 meters per second. And then we also determine the final velocity of the wind as it reaches the ground, which is 5.197954 meters per second. We use the kinematics formula again, another kinematics formula, to find the distance given the final initial velocity and acceleration. So given that value, we know that the balloon accelerates 0.144 to 18307 meters per second squared horizontally as it travels downwards. Then, given that acceleration, we use the same kinematics formula to find the total horizontal distance that the balloon has covered as it travels downward. So, plugging in the previously acquired values, we find that the balloon with the paper travels 446.98 meters from the maximum height all the way down to the ground. So we know that the total distance covered is equal to the horizontal distance it traveled as it goes way up, and the horizontal distance it traveled as it goes down. And we summate the computed values we have earlier, which is 923.013 meters plus 446.9835 meters. And from here, we conclude that the balloon in the setup and the given weather conditions has traveled a total of 1,369.99 meters, or approximately 1,370 meters. That concludes the problem solving. So, based on this presentation, masasabi ba natin na safe lang magpalipad ng balon? Anong masasabi niya dito? So, i-recap natin na bumalik ang height na na-travel ng balloon is 12,528 meters, while the horizontal distance na na-travel is 1,369 meters. So, makikita natin na based sa computation and the given wind speeds, ang balloon ay magta-travel ng 1,369.70 or approximately 1,370 meters horizontally sa ganong oras, and makaka-travel yan ng height na 12,528 meters. So, tingin nyo, masasabi ba natin na safe lang magpalipad ng lobo ngayon?
Oo, para sa akin. Wala na naman yung dagat. Malayo kami sa dagat. Within 2 kilometers siguro. So, tingin ko safe naman.
Kami rin nasa gitna ng kalupaan ng lugar namin. Kaya safe lang din sa amin. Tingin ko ito na ang tamang oras para gawin natin ang ating nakasanayan. Kaya tayo ay magpalipad na ng lobo. Para kay Bert.
Sige. Yung lobo pala, mukhang safe naman. Pwede na tayo
Sa amin
magpalipad.
din mukha namang safe kasi nasa gitna rin kami. Kaya siguro naman mukha naman pwede tayong magpalitan. Tara na pre, palipad na tayo para ano na natin.
Okay,
Tama.
tara.
No, sakto na sa labas si Jet. Sige, men.
Ako rin ay lalabas na. Maraming salamat sa inyo. Katulad ko, mag-ingat din kayo.
Kita-kita na lang sa susunod.
Kita-kita tayo. Salamat.
Salamat.
Nung high school tayo, ikaw ang unang nagturo sa akin ng basic chords sa gitara. One day, naglalaro lang ako ng chords, tapos bigla kang tumugtog ng solo mula sa kawalan. Wow bro, paano mo ginawa yan? May kanta ba akong tinutugtog? Tapos sabi mo, wala pre, nag-improvise lang ako. Until now, I'm still amazed with how you're able to improvise like that. It's something like being able to think with your feet. The longer I dwell in this life, the more I learned how important it is to be prepared for whatever life throws for us. I may never get the time to learn improvising on guitar anymore, but you're still teaching me every day like you did that day. See, you still resonate within us. You're still alive within us. That is why, in simple ways such as today, we celebrate your life. You will always be remembered. And every time, I still have this gratitude for being able to know you. So, cheers from all walks of life and death, my friend. Until then,
Isang taon na naman pala, kaibigan. Musta ka na dyan? Maligaya ka ba dyan ngayon? Tagal-tagal na din huli natin laro Hindi ko nga alam kung marunong pa ako mag-basketball Paano na yan? Mukhang hindi na ako makakabawi sa'yo Alam mo naman kasi ginalingan mo masyado Malinaw pa sa amin lahat ng mga pangyayari. Wala naman na-expect sa atin na gano'n nakabilis magbabago ang lahat. Pero thank you, kaibigan. Lahat ng iniwan mo sa amin, lahat ng memories and all those times na magkakasama tayo naglalaro, tumutugtog at kumakain. Hindi namin malilimutan lahat yon. I hope you're now happy and at peace. Sana masaya ka dyan na naglalaro, kumakain, tumutugtog. Sa araw na ito, bawat taon, we celebrate the great life that you've lived. And as long as one of us is here, we will forever remember you and your legacy lives on with us.
Sorrow fills our heart during this sad moment, a sorrow that is deep and personal. Ted Mart has silently closed the door of life and departed from us. Our lives will be empty in the years that he had brightened for us. Ted Mart was someone who gave so much happiness in our lives. He was full of love, life, and he was downright fun. Most importantly, he had an eternal love for his family and friends. We met when we were 10 years old. He had a strong connection with the many animals he cared for over the years, especially his birds. His birds was passion for Tedmar throughout his entire life. I can remember at a young age watching how as he would watch his birds. Tedmar found so much pride in his accomplishments in school. His sense of humor, intelligence, and love for birds connected him to his friends and family.
Mga tropa, salamat na kahit sa maikling panahon na paramdam niyo sa akin ang kasiyahan ng mga magkakaibigan. Sa susunod na panibagong buhay ulit, paalam.